Welcome back, students. In the previous lecture video, we already discussed on the work done required for multistage compression process. Now the next topic is what are the conditions to get the maximum efficiency from a compressor or from a multistage compression process, right? So this is the topic for today's class. Now, as you know that the total work done required for the multistage compression process from the previous lecture video, we already have some knowledge on that. The total work done required for multistage compression process is W is equal to N by N minus 1 into P1 P1 into P2 by P1 to the power N minus 1 by N plus P3 by P2 bracket closed and minus, sorry, this is not his plus, this is basically minus 2, right? Now these are the algebraic equations. The total work done required for this one. As we know that N by N minus 1 into P1 by N, we assume that this term indicates as K here, okay, and N minus 1 by N is basically indicated as A. Now we can write down these equations in terms of here that N by N minus 1 into P1 P1, we assume that is equal to K. So put down this value, this is for K here, right? Bracket open. Now P2 by P1 to the power N minus 1 by N is equal to A here. So write down this in terms of N minus 1 by N is equal to A. So this also A here minus 2. Now ultimately the equation becomes W is equal to K into this one, right? Just go through it. And now the main conditions. What are the conditions for the maximum efficiency? So as you know that the expression suggests that here P1, P3 and P2 is common here. So when you want to get that maximum efficiency, you can as you know that you can differentiate with respect to P2 here, differentiate with respect to P2. As you know that P2 is common in both terms, so you can write down that differentiate with respect to P2 and equating to 0. So next equation, so as you know W is equal to this one, so dW by dP2 is equal to this one. If you get differentiate this equation, you can get this one, right? Any problem? So I think this is fine. Now K into P into P2 by P2 to the power A minus 1 into P1 to the power minus A plus of K into, so that P2 here, so that is P2, so minus A here into P3A. Now P2 N into N minus 1, so minus A minus 1 is equal to 0. Now so this will be 0 to get the maximum conditions for the maximum efficiency, to get the maximum condition to maximum efficiency. Now K into A1, so P2 into A into P2, so P2 will be in the downwards directions, so P2 into the lower directions, so obviously P2 to the power A to the divided by P2 into P1 to the power minus A plus of K into, so plus of K minus A, this minus will be cancelled out, so is equal to 0. So after all, this equations becomes actually P2 by P1 to the power A is equal to P3 by P to the power A. So both A actually here will be cancelled out. So after all, the P2 square, so P2 here, so P2 square is equal to P1 into P3. So what is P2? P2 is your intermediate pressure. P2 is your intermediate pressure, mind it. So P2 is your intermediate pressure, right? So this is your intermediate pressures, and P1 is your initial pressure of the multistage compression process, initial pressure, sorry, and P3 is your final delivery pressure, So P2 square is equal to P1 into P3. Now you can write down P2 is equal to under root of P1 P3. So intermediate, so the condition is that for the maximum, to get the maximum efficiency on multistage compression process is that, so intermediate pressure is equal to geometric mean of or geometric product of geometric mean of initial pressure and final delivery pressure. So P2 is equal to under root of P1 P3. So this is the condition for to get the maximum efficiency, or to achieve the maximum efficiency. So P2 should be under root of P1 P3. So that is intermediate pressure under root of initial pressure into final delivery pressure. So this is the condition for to get the maximum efficiency. Okay, so go through the study material also. You can go through the study material or the lecture video also. So thank you very much for listening me and watching me. So goodbye.